Hello student, in this lecture we are going to study what an anti-symmetric relation is. Usually there is a misconception among the student that a relation which is not symmetric is said to be anti-symmetric. No, this is not how you define your anti-symmetric relation. So for anti-symmetric relation, it is prerequisite that you should be good with biconditional logical connectives. If you are not, don't you worry. I do have something which will help you out to check whether a relation is anti-symmetric or not. But if you know, then it's just a piece of a cake. So without any further ado, let's get started. First of all, just have a look on how do we define this anti-symmetric relation there. If a comma b belongs to R, b comma a belongs to R, it implies a is equals to b. Now please pay attention there. There is a logical by conditional connectives there, IFF. It means if and only if. But right now we are not focusing on this biconditional logical connectives right now. I'm just going to give you a couple of direction which will help you out to understand this anti-symmetric relation. So what steps would you count? The first one is you will start checking its ordered pair. If you see there is a comma b in relation R, then do try to find out whether there is a b comma a or not. Did you understand your first step? If there is a comma b, you will ask yourself whether b comma a is there or not. So now if if you fail to find out any b comma a there, then your relation is said to be anti-symmetric, because by default there isn't any counter ordered pair corresponding to a comma b, so that you can compare your relation. But if you do find out yes, there is a b comma a there, and it is given that, or if you figure it out that both these values are not equal. If they are not equal, then it is not anti-symmetric. But if they are equal, say it's just like 1 comma 1, 1 comma 2 and 2 comma 1 are there, then you know one is not equals to 2. If it is not equal, then obviously it is not symmetric. But somehow with some logic, if both the elements of ordered pair are equal, then it will be your anti-symmetric. So you come to know what steps are there. All right, so we'll be applying these steps in a bunch of example. So let's get started. In the first one, our relation is given to us and its order pair are 1 2 2 3 and 4 5. The moment I see 1 comma 2 there, I will just looking after for if there is in 2 comma 1 or is there or not. But unfortunately there isn't any 2 comma 1, no counter element corresponding to 1 comma 2. So your relation is anti-symmetric corresponding to element 1 comma 2. Now regarding 2 comma 3, the moment I see 2 comma 3 there, I'll check whether there is any 3 comma 2 ordered pair or not. If there isn't any, then again you have to call your relation is anti-symmetric corresponding to element 2 comma 3, and same definition or same explanation will go with element 4 comma 5. So we end up that on this conclusion that relation R is anti-symmetric. Easy. So if it is easy, then we'll just use our logics again to check whether these particular relations are anti-symmetric. I think we are done with symmetric ones, so it will not take a just take a moment to check whether which of the following is symmetric or not. First one, obviously it is symmetric. Second one, obviously it is symmetric. Third one, no, it is not symmetric. Fourth one, no, it is not symmetric. So this are the conclusion regarding your symmetricity. But right here we are dealing with anti-symmetric relation. So let's check whether R1 is anti-symmetric or not. The moment I see 1 comma 1 there, I'll check whether another element b comma a. Remember, if a comma b is there, I'll be checking b comma a if it is there or not. But 1 comma 1 is there, and obviously it's if I swap the position, still it will be 1 comma 1. So yes, it's a counter element of 1 comma 1 is itself. So your and both the values are equal, by the way. So your relation is anti-symmetric corresponding to 1 1 as well as corresponding to 2 2. So there we go, your relation is said to be anti-symmetric. Relation R1 is anti-symmetric. Now let's move to R2. I see 1 2 is there, so I'll check whether 2 1. Yes, 2 1 ordered pair is also there. Now I'll check whether 1 or 2 is equal or not. No, they are not equal. So if they are not equal, then your relation R2 is not anti-symmetric. obviously it's not anti-symmetric, so you don't have to check further, just like whether 2 comma 3 is there, though it's anti-symmetric, it's not anti-symmetric again corresponding to these two elements, but you don't have to check it anyway. Now let's check whether your R3 is anti-symmetric or not. 1 comma 1, 1 comma, regarding 1 comma 1, R3 is symmetric. For 2 comma 2, obviously it is symmetric, but at the moment I see 3 comma 4 there, my brain will start searching whether there is any 4 comma 3 or not, but unfortunately there isn't any 4 comma 3 there. So if 4 comma 3 is not there, so by default R3 is anti-symmetric corresponding to what element? Corresponding to element 3 comma 4. It is already anti-symmetric corresponding to former to ordered pair, so your relation will be anti-symmetric. Wherever if you look at the relation number R4, 1 comma 2 is there and its counter element 2 comma 1, obviously it is there, both values are not equal, so this will make your relation not anti-symmetric corresponding to 1 comma 2. So you don't have to check further whether 3 comma 4, and again you need to trapped whether 4 comma 3 is there or not. It will not affect. If a single element is responsible or is not fulfilling the criteria, your whole result will go with that single element, that your relation is not anti-symmetric. There you go. Let me take one more example. It's a relation which is defined in set n, said to be a natural number such that x divides y. So if x divides y, so a bunch of ordered pair will be there, such that 2 divides 4, 1 divides 2, also we have 1 divides 1, then let me take a few more, 3 divides 9, and there we go, 3 divides 3 also, then 5 divide 5, so on and so forth. So many will be there, but these are a couple of there. So the moment I see that you see 1 comma 1 is there, so it's counter of 1 comma 1 is itself, and obviously both the values a comma b are equal. So if it is equal, your relation is anti-symmetric corresponding to 1 comma 1. But the moment I choose this element 2 comma 4, I'll start looking for whether there is a 4 comma 2 or not. But unfortunately I end up getting no 4 comma 2 there. There isn't any 4 comma 2, or there isn't any 4 which divides 2. So if 4 comma 2 is absent there, I have to declare that my relation is what? That my relation is anti-symmetric corresponding to elements 2 comma 4. Do let me your opinion whether this whole relation is said to be anti-symmetric or not in comment box. I'm just curious what your result will be if your particular relation anti-symmetricity is there corresponding to these two elements. Do let me know. So now before we end this chapter, just quickly go through this inverse of a relation. So inverse of a relation, if relation R is given to us from set A to set B, then inverse is denoted by R inverse. R inverse, it doesn't mean that it is 1 by R. No, this is not your algebra. This is a relation, and things doesn't work like this. R inverse is just the notation for a inverse of a relation R, and it is defined from B to A, and defined as R inverse is an ordered pair in that format B comma A. It look like we just swap the position of ordered pair from relation R. Say if I have these element in set A, say we have A comma B comma C, and it is related with the element 1 comma 2 comma 3 in such a manner that A is associated with 1, B with 2, and C with 3. So a relation from A to B, then elements of set A which are participating, they are said to be the domain for relation R. Similarly, elements from set B which are participating, they are said to be range of relation R. So if we are defining any inverse relation, then range of a relation R will eventually become domain of relation R inverse, wherever domain of R will become, eventually it will become range of function R, range of relation R inverse. So let me just solve this question quickly. We have a relation R on set A defined such that x plus 2y is equals to 10. All right, so I need to express R. I need to find out their domains as well as their codomain. So to get their domain, elements of domain and codomain, may I write x is equals to 10 minus 2i? Yes, this is for relation R. This is how your relation R is defined. Since A is limited to first 10 natural number only, so let me put different values of y there. For y equals to 1, I'll get x is equals to 8. For y equals to 2, I'll get x is equals to 6. For y equals to 3, I'll get x is equals to, how much will it be? 4. And for y equals to 4, I'll get x is equals to 2. I don't need to put further values because this will be beyond set A. So this is how elements from set A, it is 2, 4, 6, 8 are associated with elements from set B, which are 1, 2, excuse me, 1, 2, 3, 4. So if I ask you what is the domain, what is the domain of function R, then your answer will be, what will be your answer? Obviously 2, 4, 6, 8 will be your domain for function, sorry, for relation R. Similarly, if I ask you about the range, then range of relation R are elements 1, 2, 3, 4, which eventually become the elements of domain of relation R inverse. Wherever, let me write it down there, domain of relation R is equals to range of relation R inverse, which is defined from in reverse order. I hope you enjoyed this lecture. So thank you very much.